Good morning, children. Yesterday we completed the exercise number 2, and then introduction to the statement of theorem number 4 was given yesterday. The theorem is called as SSS, Congruence Rule. We will today prove this theorem, and then in case the time allows, we will prove the next theorem, also theorem number 5, called Rhs Congruence Rule. With that, the proofs of our theorems will be over. Congruency rules, theorems on congruency rules will be over. We were yesterday told this theorem states that in two triangles, if corresponding sides are equal, then the triangles are equal. Triangles are congruent. Means if three sides of one triangle are equal in length to the three sides of another triangle, then the two triangles are congruent. Let us draw the diagram. We'll draw two triangles. Consider this to be the first. Let us name ABC. And let us use this as the second triangle. We'll name it as PQR. These are the two triangles, and according to the statement, what do we have? Three sides of first triangle are equal to three sides of another triangle. You have to choose corresponding sides. Let us consider the length of side AB is equal to the length of side PQ. I have shown these equal sides by one short line on both of these, showing these are equal. We'll then consider side BC equal in length to the corresponding side QR, and side AC equal in length to the corresponding side PR. Three sides of one triangle are therefore equal to the three sides of another triangle. This is given to us. We have to prove these two triangles are congruent. That will be our to prove part. Given and to prove. Given is two triangles in which three sides of one triangle are equal to the corresponding sides of another triangle. What is to be proved? Triangle ABC is congruent to triangle PQR. Now this theorem is proved by using some construction. Earlier you were told in some geometrical questions, the statement which is given does not involve information sufficient. The information there is not sufficient to prove that result. In such cases, what we do, you were told last time, that you have to do some construction. Some extra information is required, which will help us then to prove that congruency, to prove that question. That we call as construction. And the construction in this case is, let us choose the second triangle. At vertex Q, we'll make an angle on the lower side of QR. An angle will be made. The angle that we'll make here will be equal to the angle which we have at the corresponding point of Q in the first triangle. First you find out which is the corresponding point of Q in the first triangle. Q is the common endpoint of the two sides of this triangle, PQ and QR. Common endpoint is Q. And then we have PQ equal to AB side here. We have to compare the triangle PQR with this triangle. We know PQ side is equal in length to AB. QR is equal in length to BC. Here Q being the common point of the two line segments. We will find which is the corresponding point, which is the corresponding point of Q in this triangle. How? We'll find, since Q is here the common endpoint, we'll find which is the common endpoint of the sides equal in lengths to these two sides, PQ and QR, in this triangle. PQ is equal to AB, QR is equal to BC, and the common endpoint here is B. Therefore, at Q will make an angle which is equal in measurement to the angle B here. Corresponding point of Q in this triangle is B. The angle at B, vertex in this triangle, equal to that will make an angle at Q on the lower side of RQ. Construction, you were told earlier also, is preferably done in dots. So this is the construction. Will make at point Q an angle on the lower side RQ. I shall give some other name here to the point. How much? Equal in measurement to the angle B. This angle I have made equal to this angle. This is the construction. Moreover, we will make this QM, let us name this point QM. Measurement of this length of QM will make equal to AB. I have already put one short line, here also one short line. Length of QM equal to the length of AB. This is the construction. What did we do? First we made at point Q an angle equal in measurement to the angle at the corresponding point of Q point in the first triangle. It was angle B. So whatever is the measurement of angle B, equal to that you have to make an angle at point Q on the lower side. Triangle is on the upper side, lower side. Moreover, the length of this arm QM of this angle we have to make equal to AB. QR is equal to BC. These are the arms of this angle. AB is the arm, BC is the arm of angle B. We have made angle here equal to angle B. Therefore, the arms of this angle will also be equal to the corresponding arms of angle B. BC is equal to QR, and then QM will make equal to AB. We'll then join R to M and also P to M. This is the construction. This figure now God will help us to prove this result that we have to prove in this question. So before I begin the proof, you write given to prove and construction quickly. Note down on your copies. Given part of this, we have two triangles in which corresponding sides are equal. So I'll write in triangle ABC and triangle PQR. We have, what do we have? Corresponding sides are equal. AB is equal to PQ. BC is equal to QR. And AC is equal to PR. This is the given information. Then what we have to prove right now? To prove, we have to prove the two triangles are congruent. Triangle ABC is congruent to triangle PQR. This is the result to be proved. After given and to prove this information, given information and to prove information we get from the statement. Now some extra information is required. We write that as construction. Now recollect what is the construction. I have just now said at point Q we have made an angle RQM equal to angle B at point Q. Draw an angle RQM equal to angle B and cut off 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 QM equal to AB. Then we also join M to R and M to P. This is the construction of this. Now this construction will then help us to prove the congruency of the two triangles. Let us write now the proof of this. To prove this theorem, we will first consider this first triangle out of the given triangles, triangle ABC, and the triangle that we got by drawing the angle at Q and joining this triangle on the lower side of QR side, that is triangle QRM. I will roughly draw these here. Triangle ABC, this one, and triangle QRM, that is formed like this, dotted lines are there. These two triangles, QRM is this triangle. We'll first prove these are congruent by the congruency rules we have earlier come across. Now in these two triangles, we have just now in construction made angle B equal to angle Q. This is our construction. We have just now did it. We also know BC is equal to QR, that was given to us. And then in construction also we made AB equal to QM. This is again the construction. We thus have three elements of this triangle equal to three corresponding elements of this triangle. Two sides and included angle. Two sides included angle here also. Therefore, these fulfill the condition of SAS congruency rule. That is an axiom. We will therefore conclude the two triangles are congruent. Let us write. In triangle ABC and triangle QRM, we have AB is equal to QM. We have done this in construction, so write in the bracket construction. We have also made angle B equal to angle MQR. Full name will be given, I have earlier also said, because many angles are formed at point Q. Full name is therefore written. This also is construction, so write construction for this also. And BC is equal to QR. This is given to us. With this information, we will conclude the two triangles are congruent. Therefore, triangle ABC is congruent to triangle MQR. SAS congruency rule we will write in the bracket. This rule we have used to prove them congruent. Therefore, knowing these two triangles are congruent, now we'll apply CPCT. Earlier, you were told the congruency of triangles we prove by using three elements as per some rule. Then, out of using those three elements, we have three more elements. Those three remaining elements of first triangle will be equal to the three corresponding elements in the other triangle. This is called CPCT. And out of those three results, we need two here for this question. What are those? We need, therefore, AC side of first triangle will be equal to MR side of second triangle. We'll call it CPCT and mark it as first. AC will be equal to MR. This is first CPCT result we need. And we'll also have angle A equal to angle at M. And since at M many angles are formed in the actual figure, this rough figure has only one angle at M. Had this been the actual figure, we would write short name angle M, but actually we have many angles formed at vertex M. Therefore, better will be give the full name QMR. We will write CPCT for this also and mark it number 2. The two results we got as per CPCT from this part of the proof. Now next we shall proceed. We already know AC is equal to PR. This is given to us. Now we have got AC also equal to MR in the first result that we proved just now. AC is equal to PR, we know it, it is given to us. Now we have AC equal to MR also. Therefore Euclid's axiom will be used. Right, also AC is equal to PR. It is given to us. And this result, given result, will compare with first relation we already have marked number 1 and apply Euclid's axiom. Therefore, from first we have. What will you have according to Euclid's axiom now? AC equal to PR, AC equal to MR. AC is the same thing, equal to two things. Result says things which are equal to the same thing are equal to one another. Therefore, we'll get PR equal to MR. PR equal to MR. Consider the figure and see. PR is here, MR is here. Now these are equal. These PR and MR form a larger triangle here. This is the rough figure. This figure is formed. Triangle is formed by these two sides. A triangle with these two sides is taken from the figure. PR and MR. Two sides are equal. And now you know these two sides are equal. We'll apply the theorem of the previous exercise. A triangle in which two sides are equal, their opposite angles also are equal. This angle, which is opposite angle of MR side, and this angle, which is opposite angle of PR side, will also be equal. We write therefore angle opposite to PR side, angle opposite to this is at vertex M, name is PMR, is equal to angle opposite to MR side is at vertex P, the name of the angle is angle MPR, is equal to angle MPR. You will put the reason, you write there the reason we have written yesterday also many times. You write angles opposite to equal sides of a triangle are equal. Angles opposite to equal sides of a triangle are equal. So we have angle PMR equal to angle MPR. You mark it number 3. Well, the triangle PMR just now we used. On the other side of this PM, we have another larger triangle. PM, we used the right side of this so far. Now to the left of this, we have another triangle. PQM is the triangle, larger triangle. I shall draw the rough diagram of this also. This is the one, PQM. In this triangle also we find two sides are of equal length. One short line on two sides we find here. PQ has one short line. QM also has one short line. Therefore these are equal. And again the same result will be used. In a triangle if two sides are equal, their opposite angles are equal. So we'll write word similarly here. Because the concept is same. Similarly angle at vertex M, the name is angle PMQ, is equal to angle at vertex P, name is angle MPQ. This is similar. In the previous case, we used the triangle on the right side of PM, this dotted line. To the right of this, the larger triangle we used in the previous case. Now we use the other triangle. This triangle also has two equal sides. One short line on this, one short line on this. Two equal sides are there, their opposite angles are equal. This is the result. These two results then will add with each other. We write by adding third and fourth. By adding. We get. We'll add LHS to LHS, RHS to RHS. Both angles on LHS have the same vertex M. Both angles on the RHS have same vertex P. We'll add them. Angle PMR plus angle PMQ is equal to angle MPR plus angle MPQ. LHS to LHS, RHS to RHS. And now when you add them, look at the figure. Angle PMQ. This is the angle PMQ. I will draw the rough diagram here. Angle PMQ, this is the one. PMQ. Another angle is angle PMR. PM is already drawn. PMR angle, to make angle PMR, this is the ray we need. PMR. These two angles are added. Now when these are added, they make a larger angle QMR. Therefore the sum of these will become angle QMR is equal to QMR. Here at vertex M, two angles we added to form the larger angle. Likewise, we have two angles at vertex P. Angle MPR. Look at angle MPR. This is the one. MPR. This angle. Angle MPQ. This angle. We have to add them. Similar figure. But it is just reversed. They make angle QMR here. Now here these will make angle QPR. Therefore is equal to angle QPR. We have added the two. Well, the two results earlier we got, we marked as first and second. I have rubbed that. You look at the first result that we had, that was AC equal to MR, marked as first. And then second result that we wrote as marked as number 2 was angle A is equal to angle QMR. This was marked as second. Out of these, first we used it earlier. Here, from first we have used it first. Second when we did not use that time. Now is the turn of using that. That second result will now compare with this result we got. Angle QMR is here, angle QMR is here. Again, Euclid's action will be used. Here angle QMR is equal to angle A. Here angle QMR is equal to angle QPR. So therefore Euclid's action will give us angle A equal to angle QPR. Things which are equal to the same thing are equal to one another. So therefore, earlier we wrote from 1 we have, now we'll write from 2 we have. From 2 we have. So what will we have from 2? Angle A is equal to angle QPR. Angle QMR will get eliminated. Things which are equal to the same thing are equal to one another. QMR was the same thing there. Things which were equal to QMR, we have angle A, we have angle QPR, therefore those things are equal to one another. This result will finally help us to prove the two triangles are congruent. We finally choose these two triangles now. Now, in triangle ABC and triangle PQR, we have. In these two triangles, we have AB equal to PQ, this is given to us. We also have AC equal to PR, again given to us. And just now we proved angle A equal to angle QPR. This is the angle included by these two sides. And here also we have included angle by SAS congruency rule. Therefore, the two triangles are congruent. AB is equal to PQ given angle A is equal to angle QPR proved above. AC is equal to PR. This also is given to us. And we'll conclude therefore triangle ABC is congruent to triangle PQR. We used SAS congruency rule to prove this. That is the proof of this theorem. Proof is a lengthier one, but you need to understand the points that I have explained clearly. I have explained in detail the points involved or the steps involved in proving this. Do it again, twice, thrice. Make sure that you have understood it. In case there is any step which you will fail to understand, do contact me on the WhatsApp. I shall explain that again. Then we have another theorem, theorem number 5, which is called as Rhs Congruency Rule. This is theorem number 5, Rhs Congruency Rule. Here R stands for right angle, H stands for hypotenuse, and S stands for side. Previously it was SSS, all S's were involved. Side, side, side. Three sides of one triangle were equal to the three sides of another triangle. Now the situation is different. It is RHS now. Means the two triangles will be right triangles here. R is for right angle. We'll have two right triangles. This rule will be applied therefore for proving congruency only in case of right triangles. Right angle. Both triangles should be right triangles. Then hypotenuse. H is for hypotenuse. Here it means the length of hypotenuse of one triangle is equal to the length of hypotenuse of another triangle. By hypotenuse we mean the side opposite to 90-degree angle. A triangle is called right triangle if its one angle is 90. Now in that right triangle, the side which is opposite to 90-degree angle is called as hypotenuse. Hypotenuse of one triangle should be equal to the hypotenuse of another triangle. And then S stands for side. Excluding the hypotenuse, there are two more sides. One of the sides you have to choose, because only one S is here. The length of one of the sides should be equal to the length of the corresponding side of another triangle. Second triangle also will have exclude hypotenuse two sides. You have to choose one side there also. But the side should be corresponding side of the side you have chosen here. Any side can be taken from the first triangle. From the second triangle, you have to then use the corresponding side. If this is the information available to us, we can say the two triangles are congruent, and the congruency rule used is Rhs congruency rule. To prove this congruency rule, let us draw the diagram. We'll draw two right triangles. The first one let us name as ABC. The second one we'll name as again PQR. Both are right triangles. This one is right angled at B, this one is right angled at Q. So both the triangles are right triangles. R is right angle. Then their hypotenuses are equal. Hypotenuse of first right triangle equal to hypotenuse of second right triangle. AC therefore is equal to PR. I have shown two short lines on both of these. Hypotenuse equal to hypotenuse. And then finally, one side out of the two sides AB and BC of this triangle, you have to choose one side. And then out of the side, remaining two sides of this triangle, you have to again choose one. But the one you will choose here must be the corresponding side of this. If you here choose the side BC, you have to choose here corresponding side QR. You cannot choose BC here equal to PQ there. They are not corresponding sides. You have to choose corresponding side. So BC we shall consider equal to QR. We decided to take BC and here the corresponding side. Had we taken AB here, then corresponding side would be taken there, and the corresponding side of AB is PQ. Then you have to choose here AB, here PQ. Those are equal. Now I have decided here in terms of BC and QR. Right angle, hypotenuse, and one side of one triangle are equal to the right angle, hypotenuse, and corresponding side of another triangle. We have to prove under these conditions also the two triangles are congruent. Now for the congruency of these two triangles also, you need to do some construction. And the construction will again be at point Q, like previous question, will make an angle equal to the angle at the corresponding point of Q in the second triangle. It is B, like in previous case. And at B we have angle of 90 degree. Will make therefore at Q also an angle of 90 degree. Dots I shall draw. Right angle will make here also. And then another thing, what we did in the previous case, the arms of this angle that we constructed here should be equal to the arms of the same angle in the first figure. Out of the arms here, we already know BC equal to QR. That was seen in the previous case also. And then second arm of this angle should be equal to the second arm here. Means AB must be equal to QM. We named M this point in the previous case also. Here we'll also call this M. So QM we made equal to AB. This is the construction. Join M to R as in the previous case. We also joined there P to M, but here that is not possible because as you join P to M, it will coincide with this line that we have already drawn there because this is an angle of 90 degree. This also is 90. This forms a linear pair. Straight line will be formed. So therefore, only one line segment you need to join here, M to R. That is the construction. We'll quickly write the given. And to prove then construction, we have two right triangles, ABC and PQR, in which angle B is equal to angle Q is equal to 90 degrees. AC is equal to PR, hypotenuse equal to hypotenuse, and one side we have taken BC equal to the corresponding side there, QR. This is the given information. What we have to prove? The two triangles are congruent. Triangle ABC is congruent to triangle PQR. To prove this, we did construction, so write construction. The construction is at Q, draw an angle MQR equal to angle B, that is 90 degrees, equal to angle B, and cut off QM equal to AB. This is the construction, and then we join M to R. Now let us write the proof of this. For the proof of this, we have similar procedure as we did in the previous case. We'll consider the two triangles, this left side triangle, the first one, original one, and the one which is formed at the lower side as we did in the previous case. These two triangles you can prove congruent. Same procedure. BC we have equal to QR, it is given to us. Angles of 90 degree we have. AB we have made equal to QM, construction. Thus we have two sides and included angle of this triangle equal to the two sides and included angle of another triangle. The two triangles therefore are congruent. Prove their congruency in triangle ABC and triangle MQR. We have BC is equal to QR. This is given to us. Angle B is equal to angle MQR. This is construction. We have made 90 degree angle. You will write each 90, or you can even write construction. This we have done in the construction. We also have AB is equal to QM. This is also the construction. With these three steps, we can therefore say the two triangles are congruent. Triangle ABC is congruent to triangle MQR. SAS, congruency rule. All this we did in the previous case also, previous proof also. And then CPCT, two results were obtained in that result, in that theorem also. Here also we need two. One of them will be AC is equal to MR. This was the one we wrote there also. CPCT, mark it first. And one angle also was taken, though there are three CPCT results. Only two are required, so we'll write two only. AC equal to MR we wrote, and we also have this angle at C vertex equal to the angle at R vertex, angle MRQ. Or even angle A we have equal to angle M. Three results of CPCT. We have, so angle A equal to angle at M vertex. This is CPCT also. Again, mark it second. Having proved this, like in the previous theorem, then we compared. We have AC already equal to PR. This was given to us. There also we did it. AC is equal to PR. But AC is equal to PR given. We compared it with first. We wrote there also from first we have. Here also we write from first we have. Things which are equal to the same thing, Euclid's action, are equal to each other. We are not doing anything new here. This is same what we did previously. Same thing we are applying. AC equal to PR by using in first. We have. So what will we have? AC will get eliminated. This is the same thing. We will have MR equal to PR. These MR and PR, earlier also you were told, steps are same. These are the sides of a larger triangle here, same single triangle. In that previous case, two triangles were formed. One was on the right side of this vertical line, dotted line there. Another was on the left side. Here you have only one part of this. Larger triangle formed. Rough figure we made there also. This is the one. We have R here. We have P here. We have M here. This is the larger triangle now we have to use. We used it the same triangle in the previous proof also. And in this triangle, we have now two equal sides. MR is equal to PR. So what will happen? Their opposite angles will be equal. Therefore, their opposite angles will be equal. Which two angles? Angle opposite to MR side is this angle, angle P is equal to. Angle opposite to PR side is angle M. Angle P is equal to angle M. The reason you will write statement of that theorem we did in the previous exercise. Angles opposite to equal sides of a triangle are equal. You note down it here. Angles opposite to equal sides of a triangle are equal. We got angle P equal to angle M. And now here the change will take place. What we did in the previous theorem will now change here. Up to this step, all the steps were same. Because there is only one part. Left side, we don't have that triangle here. Previously there was another triangle on the left side also. We don't have now. There was only one part. Therefore, directly we'll compare it with 2 now. In the second result of CPCT, we had angle M equal to angle A. Here we have angle M equal to angle P. Again, Euclid's action will be used. Angle M will get eliminated. What will we have therefore? Angle A equal to angle P. Right? By substituting in second, we have angle A equal to angle P. Euclid's action. And finally, what we did in the last step there, these two triangles now can be proved congruent. Angle A we now know is equal to angle P. We also have angle B equal to angle Q, each 90. Two angles of this triangle are equal to the two angles of this triangle. And then we also have BC equal to QR. This therefore fulfills the condition of corollary. If two angles and any side of one triangle are equal to the two angles and corresponding side of another triangle, and the two triangles are congruent, that will complete the proof of this. So you write the last steps, congruency of these two triangles. Right now, in triangle ABC and triangle PQR, we have AC equal to PR given angle A is equal to angle P. We have just now proved, so write proved above. We also have angle B is equal to angle PQR, each 90 degrees. Therefore, the two triangles are congruent. Triangle ABC is congruent to triangle PQR. We have used SAS congruency rule. That completes the proof of this theorem. With that, we'll conclude today. The application part of this exercise number 3 will start tomorrow.